this video we will be looking at a series of exam style questions from past papers and going through them together. So looking at this first question here, we can see that we've got a fraction with surds on the numerator and the denominator, and we need to rewrite this in this form. Now straight away, when we see a surd on the denominator, we know that we need to rationalize the denominator. But before we do that, just having a look at this question here, we see root 180, and with that being a large number, it looks like this surd can be simplified. So I think we can approach this question in two steps. One being, if we simplify all surds, so simplify the surds if possible. And then once that's done, we can go ahead and rationalize the denominator. So starting off, if we take 180 and we want to simplify this, the largest square number that goes into 180 will be 36. Then we multiply that by 5. Root of 36 is 6, so instead of root 180 we have 6 root 5. So we can go ahead and replace 180 with this. So if we rewrite this fraction, we get 6 root 5 minus 2 root 5 over 5 root 5 minus 5. Here the surds have the same number inside, so we can minus these. This will leave us with 4 root 5 over 5 root 5 over 5. So it can't be simplified any further, so now we can go ahead to the next step and rationalize the denominator. So we're going to be taking this fraction and as we can see, there is a surd in the denominator, but there is also a minus sign. So in order for us to rationalize this, we're going to have to multiply it by the full denominator, but we're going to flip the sign. So it's going to be a plus here. And multiplying across as normal, this will give us 4 times 5, which is 20. Root 5 times root 5 is 5, so 20 times 5, which is 100, plus 20 root 5. 5 root 5 times 5 root 5. 5 times 5 is 25, times by 5, 125. Plus 25 root 5. Minus 25 root 5 minus 25. Now we collect the like terms. Plus 25 root 5 minus 25 root 5 is 0, so we can cancel that out. So we're left with 100 plus 20 root 5 over 100. Now if we simplify this, we can split up this fraction, so that will give us 100 over 100 plus 20 root 5 over 100, and this is the same as 1 plus 20 over 100 is the same as 1 over 5, so here we will have root 5, because root 5 times 1 is root 5, over 5. And that is our final answer. And if we look here onto the question, it is in the same format as a plus root 5 over b, where a and b are integers. So we can write that a equals 1 and b equals 5. On to the next question. We need to show that 8 plus root 12 over 5 plus root 3 can be written in the form a plus root 3 over b, where a and b are integers. Now again, in this fraction we have surds, and we have a surd in the denominator, so straight away we know that we need to rationalize the denominator. However, just before we do that, we recognize that root 12 can be simplified. So it might make it easier for us to simplify first and then rationalize the denominator to save us from further simplifying down the line where we have larger numbers. So again, just like the previous question, we're going to start off with simplifying the surds if possible. And then continue to rationalize the denominator. So root 12 is the same as root 4 multiplied by root 3. Root 4 is 2, so our final answer is 2 root 3. So now instead of root 12, we can substitute in 2 root 3. So if we rewrite this fraction, we get 8 plus 2 root 3 over 5 root 3. And now we need to rationalize this, so we're going to multiply by the whole denominator and flip the sign. So we're just going to multiply across as normal. 8 times 5 gives us 40. 8 multiplied by root 3, 8 root 3. 2 root 3 multiplied by 5 gives us 10 root 3. 2 root 3 multiplied by root 3. The root 3's cancel each other out, so that leaves us with just 3. So 3 times 2 is 6. For the denominator, 5 times 5, 25, minus 5 root 3, plus 5 root 3, plus and a minus, minus 3. So now we're going to collect the like terms. 40 minus 6 is 34, minus 8 root 3 plus 10 root 3 gives us positive 2 root 3. Minus 5 root 3 plus 5 root 3 is 0, so that cancels out. So we're left with just 25 minus 3, which is 22. Now we can see here that all of these integers are even numbers, so we can simplify this down further by simply just dividing by 2. So if we do that, that gives us 17 plus root 3 over 11. And if we look at the question here, this final answer of ours is in the same format as requested, a plus root 3 over b. So we can write down a equals 17 and b is 11, and that is our final answer. For our next question, we're given this equation, root 5 bracket root 8 plus root 18 bracket, and we need to show that this can be written in the form a root 10, where a is an integer. Now we know, again, we need to just multiply this out. But again, just like the previous questions, I can see that we can actually simplify these two surds before moving on. So we can go ahead and simplify first before multiplying out. Root 8 is the same as root 4 multiplied by root 2, which gives us a simplified answer of 2 root 2. Root 18 is the same as root 9 multiplied by root 2, which gives us a simplified answer of 3 root 2. So now we can just sub these numbers in. Now we are going to have root 5 multiplied by 2 root 2 plus 3 root 2. And if you look at that, the surds have the same number inside, so we can go ahead and actually add these two together, which will give us the number inside the bracket as 5 root 2. So now we just need to multiply 5 root 2 by root 5. We times the surds together, so that will give us 5 root 10. 10 can't be simplified down any further, so that is our final answer in the same form as requested in the question. So we know that A equals 10. And just a quick note on this as well, we could have gone ahead and multiplied across just like this without simplifying, which would have been fine too. We would just need to simplify further down the question. So whichever way you find easiest, go ahead with that. You will get the same answer in the end. Looking at another question, here it says show that 6 minus root 8 over root 2 minus 1 can be written in the form a plus b root 2, where a and b are integers. Now straight away we see that there is a surd on the denominator, so we know for a fact we need to rationalize the denominator. But again, before that, just looking at these numbers, root 8 we know can be simplified, so before rationalizing the denominator we can go ahead and simplify this surd and then carry on. So I'll write it here on the side again. Simplify the surd, then rationalize the denominator. So root 8 is the same as root 4 multiplied by root 2, which is 2 root 2. Now we just need to substitute 2 root 2 where we see root 8. So this is the same as 6 minus 2 root 2 over root 2 minus 1. Now that we've simplified this surd, we can go ahead and rationalize the denominator. There is a surd in the denominator with a minus sign, so we're going to multiply by the whole denominator, but we're just going to flip the sign. And multiplying across as normal, get 6 root 2 plus 6 minus 4 minus 2 root 2. The same for the denominator. Root 2 times root 2 is 2 plus root 2 minus root 2 minus 1. So we go ahead and collect the like terms. 6 root 2 minus 2 root 2 gives us 4 root 2. Plus 6 minus 4 gives us positive 2. For the denominator, plus and a minus, these cancel out. 2 minus 1 is 1. So that just leaves us with 4 root 2 plus 2. And we're going to just rearrange this for the question, where we have the integer first and then the surd after. And as you can see, that is now in the same format as requested in the question, a plus b root 2, where a equals 2 and b equals 4. Looking at this question here, it says Martin did this question. Rationalize the denominator of 14 over 2 plus root 3. And it shows us how he answered this question. And here it says Martin's answer is wrong. Find his mistake. So let's go through this question together. To rationalize the denominator, we will have to take this fraction and multiply it by the whole denominator and flip the sign. Which we can see here he has done. So 14 multiplied by 2 minus root 3 over 2 plus root 3, 2 minus root 3. So far he's on the right path. So if we multiply this across, we will get 28 minus 14 root 3. The bottom we will get 4 minus 2 root 3 plus 2 root 3 minus 3. So let's compare that to his work. 28 minus 4 root 3, 4 plus 2 root 3 minus 2 root 3 plus 3. So as we can see here, this might be where he went wrong. When we multiply positive root 3 by negative root 3, we're multiplying a surd with the same number inside, so we get rid of this surd. That gives us just 3, and it's a minus. Plus and a minus gives us a minus. He has gone on to add 3, so it looks like that's where the issue lies. So let's carry on with this question and see what our simplified answer will be. Yep, it looks like that is it. So instead of it just being over 1, which will just be this on the numerator, he's got 7 because he has added 4 and 3 together and therefore started to simplify it and is giving him a completely different answer. So his mistake was he calculated root 3 minus 3 root 3 as plus 3 instead of minus 3, giving him an incorrect answer. There is a part B to this question. It says Sean did this question. Again, they are rationalizing the denominator. Here we have 5 over root 12. It shows how she answered this question, and again her answer is wrong. Find her mistake. So if we go ahead and rationalize this denominator, so root 12 we're going to multiply by root 12 over root 12. We can simplify this after, that's fine. That gives us 5 root 12 over 12. And looking at her working out, she's done the same thing, 5 root 12 over root 12 multiplied by root 12. So that's fine. Now root 12 can be simplified. So it is the same as root 4 multiplied by root 3. That gives us 2 root 3. So now we will write 5 multiplied by 2 root 3 over 12. But here we can see that Sean has written 3 root 2 instead of 2 root 3. So that's where the mistake is. So she has simplified root 12 as 3 root 2 instead of 2 root 3. And just a little side note here, this is a small mistake that any student could make, so it is always good to check your work thoroughly and make sure all numbers are correct. Now this will be the last past paper question for this video. Here we need to rationalize the denominator of 22 over root 11, giving our answer in the simplest form. So for this we just need to multiply by root 11 over root 11. 11 is a prime number, so we can't simplify this down anymore. This will give us 22 root 11 over 11. 11 goes into 22, so this can be simplified. 11 goes into 22 twice, so that is 2 root 11 over 1, which is the same as 2 root 11 as our final answer. Part B, show that root 3 over 2 root 3 minus 1 can be written in the form a plus root 3 over b. So again, straight away we can see there is a surd on the denominator, so we need to rationalize this. These surds can't be simplified down any further, so we can just go ahead and continue with rationalizing the denominator. It's going to give us root 3 over 2 root 3 minus 1, and we're going to multiply by the whole denominator and flip the sign. Now if we go ahead and multiply across as normal, root 3 times root 3 is just 3, 3 times 2 is 6, root 3 multiplied by 1 gives us just root 3, 2 root 3 times 2 root 3, multiply the integers together gives us 4, root 3 times root 3 is just 3, so 4 times 3 gives us 12, plus 2 root 3 minus 2 root 3, positive and a minus gives us minus 1. Now we just need to collect the like terms. We can't do anything for the numerator, so that will stay as is. For the denominator, plus 2 root 3 minus 2 root 3 cancel out, so we're left with just 12 minus 1, which is 11. And these two numbers here can't be simplified down any further, so this is our final answer, and we can see that it is in the same form as requested in the question. So now we can write that A equals 6 and B equals 11. Now this is the end of the Surds video series. If you got all of these questions correct, well done. If you're still not sure about some of them, go back in the video, look at the methodology and browse through some of the previous videos that we have on the channel to understand the concepts better.